Webster's dictionary defines reliability as the quality or state of being reliable. Okay, very helpful. Or alternatively, as the extent to which an experiment, test, or measuring procedure yields the same results on repeated trials. All right, that's a lot closer to today's Chalk Talk, which is all about the reliability of our electronic components. What does it mean to be reliable in the EE ecosystem? How is reliability determined? How does it differ from one market segment to another? Well, my friends, we have answers to all of that and more. Hi, I'm Amelia Dalton, host of Chalk Talk. Reliability is cornerstone to all electronic designs today. But how reliability is implemented and determined can vary widely by different market segments. In this episode of Chalk Talk, Sam Accardo from the YAGEO Group and I explore the definition of reliability for electronic components, investigate the different grades of reliability offered by the YAGEO Group, and the various steps that the YAGEO Group is taking to ensure the greatest reliability of their components. And before we get started, don't forget to click that link. There you can find even more information about this topic from the YAGEO Group. Hi, Sam. Thank you so much for joining me.
Hi, Amelia. Thank you for having me today. I appreciate it.
Absolutely. Okay, so today we're discussing what reliability means in the world of electronics. But, Sam, can you first explain to us who are not in the manufacturing world what it means to make something reliable?
Absolutely, I can. And it's a very good question. And what I think I'll start with is actually explaining reliability in the terms of something that I think most people have in their household, which is a knife. They come in a lot of different form factors. They're manufactured in different ways in order to meet different application conditions. And so I think it's a good way to really explain what a reliable component or a reliable system actually is. So I'll start off by talking about the applications. When we look at a kitchen knife as an example, there's a lot of different types of kitchen knives. There's chef's knives, there's paring knives, serrated knives, filleting knives. Each of these different types of knives are created for slightly different applications. So a chef knife, as an example, I think it's the more rounded type of knife for a kitchen. It's versatile. It's used for really all different purposes inside of a home kitchen or within a restaurant kitchen. And really its whole purpose is to slice and dice, chop vegetables, meats, whatever it may be. The knife itself has a broad blade, it's slightly curved edge, and that really makes it easy for a rocking back and forth motion that you would need for cutting all of these different types of fruits, vegetables, and meats. A serrated knife, on the other hand, has a lot of different edges cut into it, and it makes it a lot easier for cutting through things that are a little bit tougher on the exterior, softer in the interior. Think things like bread or tomatoes. There's also boning knives, which are typically very thin, flexible blades. They're used to cut things like meat and fish. Filleting knives, on the other hand, very similar to boning knives. They're basically a little bit thinner, more flexible, and they're specifically designed to, fillet fish. And then you even have something like a cleaver, and it's a big squared or rectangled type of blade, and its whole purpose is to chop through things like bone or tough meats. Now, if we look outside of the kitchen, there are a number of different types of knives as well. There's disposable knives. Those are typically made of plastic. They're low cost. And really the whole idea is you use them once. They may or may not break, and then you get rid of them after using them. There's also pocket knives. They're basically designed to be versatile. You could use them for a number of things like wood carving, but you could also use them for things like cutting food. And then there's things like swords, which a samurai sword being a very good example. The katana, its whole purpose was to be used in battle. So each and every one of these different types of knives are used for different purposes. And the way that we manufacture them, the material set that we use, has some type of influence on that. If we think about the materials as another part of this, stainless steel as an example, it has a high resistance to rust and corrosion. The technology is very durable. It makes it very easy to maintain. The problem is that it dulls out pretty quickly, meaning it doesn't hold an edge. On the opposite side of that, there's carbon steel. Carbon steel holds up very well in terms of its edge, so it has excellent cutting performance. But unfortunately, it's very prone to rusting and staining. And so much more care needs to be taken for that type of steel. Now, there's also high carbon steel, which is really a combination of the carbon steel and the stainless steel. And it's basically the best of both worlds, but typically it could cost a little bit more. There's also materials like ceramic. Ceramic is very hard and it holds a good edge, but it's very prone to chipping. And so if it's not handled properly, it could end up with some issues. So choosing the right type of material to create the knife that the consumer is looking for is very important as well. And then, of course, you have things like the manufacturing process. So there's forged knives, which is basically where you take a single piece of metal and that is heated and hammered into a certain shape. The actual knife itself, when it's manufactured through this forging process, is much more durable, balanced, and it actually maintains a better edge retention than some of the other processes. If we look at stamped knives, on the other hand, that's where there's a large sheet of metal, and basically each and every knife is punched out of that. It's a lot less expensive to produce. But when you take down the reliability of that type of knife, which is the forged part of that, you end up with a knife that is functionally less reliable or durable than the other technologies. And then, of course, you've got plastic as another technology. I don't know the last time that you may have used a plastic knife to cut a steak. It breaks apart pretty quickly. Basically, that technology is taking plastic and molding it into a certain shape. It doesn't have great ridges on it. It's not very durable. So in total, even the manufacturing process of how we build those types of knives has a little bit of effect on its reliability. And then the last part of it is really the overall cost, because the more reliable you make something, the more it's actually going to cost you. So if we look at price, disposable knives are going to be the most low cost. They're the highest running mass produced versions of knives. And then, of course, the step up above that, you have budget friendly, which is also mass produced using economical materials, much more economical than, let's say, like a katana as an example. You have mid-range knives, which are a balance between the quality and affordability. And then you even have the high-end premium knives, which use really the best materials, the best processes. So in summary, I mean, depending on what the actual end user's purpose is or what they're going to use the knives for, there's going to certainly be a difference in material, difference in manufacturing process, and really a difference in the reliability of the overall knife. And that corresponds back to the components that we make with the YAGEO Group. The same case still stands.
Wow. So that's a lot that goes into making a knife, or a component for that matter, reliable. So where does the YAGEO Group fit in?
Absolutely. So the YAGEO Group is actually a company with multiple brands that have been acquired over the years that really manufacture products that fit different applications, different market segments. If you take YAGEO, the company, as an example, YAGEO is one of the world's largest manufacturers of chip resistors. They service really all of the consumer type markets, consumer, industrial, telecommunications, data center servers. If we look at the Pulse brand, which is another major brand, they manufacture magnetics, again, serving really those same markets. If we look at Kemet as a brand, Kemet manufactures mostly capacitors, one of the largest manufacturers in capacitors, especially for high reliability applications. So not only does this brand serve, I guess, the consumer and automotive markets, it also serves the high reliability markets, including downhole, military, medical, and really the components that Kemet manufactures for those market segments or those applications is going to be a lot different than what you would find from some of the components from YAGEO Pulse. The components manufactured from Kemet for commercial and automotive may be very similar, but the high reliability components, just like with knives, they're manufactured with better material set, better processes, and the design of those components is really built to not fail. So I guess the overall look at the YAGEO Group is that YAGEO is a electronic component supplier that really provides solutions for anything that consumes electricity. Now, if we look at the different types of products that the YAGEO Group manufactures, like I mentioned, there's the capacitors, resistors, the magnetics, but there's also all these other technologies. And, like I said, in a lot of cases, a lot of those products are tailored to certain applications, certain market segments. But the YAGEO Group has a number of different types of components that we work directly with our end customers on in order to determine what their requirements are for reliability, for design, for electrical characteristics. And then we build components, customized components that fit those needs. So the YAGEO Group not only builds standard components set to fill the need in different markets, we also build customized solutions for customers that have very specific needs that are outside of our standard portfolio.
So let's talk about those market segments. What are the requirements of components for those different market segments?
While each and every market segment has their own requirements, some of the consumer electronics are looking at components that are being designed for not just high volume, but also low cost. If we look at telecommunications or data centers, they're typically looking for components with higher efficiency. If we look at the automotive market as another example, the automotive market is usually looking for components that will last a certain lifetime, that are efficient, that are going to help their design really last a long time within the market itself. Automotive is seriously a harsh environment. So the components themselves have to be able to withstand that harsh environment. If we look at something like downhole as another example, typically those types of components require, I guess, excessive heat, basically very brutal, much more brutal than automotive. But typically the lifetime is only, in some cases, down to a few minutes. It's typically not going to be years like an automotive component. And then if we look at the high reliability market, meaning medical or aerospace and defense, if we take a look at what's currently showing on the screen, we have reliability grades ranging from commercial to space grade or military grade. Those types of components are designed to not fail. Now, of course, we stand behind all of the different products that we make at the YAGEO Group for all of the different reliability grades. But when you look at a high reliability component, that component has not only got a more conservative design, it's using better materials manufactured on a separate line. And really, we test the component in order to weed out any part that may fail. So the requirements that each market is actually looking for is slightly different. And when we look at where the YAGEO Group kind of fits in, we basically keep ourselves involved in a lot of the agencies or standard committees in order to ensure, one, we understand what our customers are going to be looking for the next 5 to 10 years out. But we also look at having people on these committees in order to really influence what we think that these standards should be. So some of the standards would be things like UL for safety caps, the AEC Q101 or Q200, so for passives and active components. And then, of course, the DLA specs like the DESI drawings or mil specs. We have people on each of these committees in order to really just understand what's going on and to provide feedback. And I've actually attended some of the meetings for CE11, which is really one of the standard committees for the aerospace and defense market. And what's very interesting is not only do you have the people involved with the DLA, you also have some of the end entities like Redstone Arsenal or Aerospace Corporation or NASA, as well as some of the larger manufacturers there, such as the YAGEO Group, and then some of our competition. And then you also have the customers that are building some of these systems. And everyone that attends these types of committees really has the ability to provide their input on what the requirements should be on some of the standards that they put out. So they'll come up with the actual standard itself, which in this case would be like a mil spec. The mil spec will talk about what the qualification requirements are, what the electrical characteristics need to be like. And then, of course, the manufacturers like ourselves go out and build components that we think will meet the requirements. And then we have to do testing in order to prove that they will. And if they don't, it's back to the drawing board. And if they do, of course, then we're able to become added as a supplier for that particular component. So there is a lot of requirements that come directly from markets. And we do try to keep ourselves involved really to understand what the requirements are going to be down the line and to ensure that we're building the components that are going to meet those requirements.
So, Sam, it seems that YAGEO has products supporting virtually every market segment. So, can you talk to me a bit more about the reliability grades you offer and What makes them different?
Absolutely, I can. It's the ability for the component under normal operating conditions to operate within the specification over its lifetime with few to no failures. So, what do we not mean by that? When we look at the component, it's not excessively mechanically stressing the component out. If you think of an MLCC as an example, they have flex ratings, typically 2, 3 millimeters. And if you flex it beyond that, they could actually develop a flex crack. We also mean excessive voltage. So if it's a 10-volt part, using it at, let's say, 15 volts. It's also excessive temperature. If it's rated to 125 degrees C, using it at 150 degrees C isn't making the component more reliable. And then also the same thing with voltage transients. Those spikes would not be considered reliability. It's the ability of using that component within the specifications that we've listed out in the data sheet and getting a lifetime that is listed in the data sheet or something beyond that. So I'm sure all of you are familiar with the bathtub curve. On the left-hand side of the bathtub curve, there's the infant mortals. That's basically the power on failures of the component. Typically, it happens because of material or processing defects. After a certain period of time, we get to the normal life of the component where there's going to be additional failures, and those are for latent defects. And then on the very right hand side, we have the wear out region, which is basically once certain conditions have been met, increased leakage current, ESR, the capacitance is out of specification, components begin to fail way later on at the end of their life. Now, what higher reliability actually is doing is number one, it's decreasing or removing the infant mortals. It's also decreasing the normal life failure rate. And then it's also pushing out the wear out region further in time.
Reliability is using a component within its specification and getting long life. Knowing that long life is the goal. So, Sam, how do we actually go about making a more reliable component?
So, the first thing I really want to mention is I think it's a very common misperception that testing makes a part reliable. I remember whenever I joined the YAGEO Group many years ago, one of the first things that they told me was testing doesn't make a component reliable. It only proves that a part is reliable. What really makes a component reliable is all the things that we do to the component during the manufacturing process. And to go back to our knife example a bit earlier, it doesn't matter what amount of testing or what type of testing you do to a plastic knife, it is never going to be more reliable than a samurai sword, as an example. Think about it. Which one would you like to take into battle? So, if we look at the chart that we have on the screen, really the first thing is the governance. So, the IEC, the AEC-Q200 or AEC-Q101, DLA, it could be UL. There's a lot of governing bodies. And like I mentioned, we work with each of these governing bodies in order to help develop some of the specifications that they have for components. These governing bodies are responsible for working with us as manufacturers as well as the customers in order to determine what the requirements actually are. And then, of course, we have to build specifically to meet those requirements. So in order to build to meet those requirements, we have to, one, determine what type of materials we want to use. As an example, I know we have different formulations for different types of ceramic materials that go into our MLCCs. Some of them are built for higher volume, some of them are built for higher reliability. So the material set, just like with choosing the different types of steel for knives, is very important. And then the conservative design that we put into it. So what that essentially means is that we have to take a component and we have to make thicker dielectric layers in the instance of a capacitor in order to get a higher voltage rating, as an example. And when you move from a commercial to automotive design, you might have slightly thicker dielectric layers. When you move from automotive up to a high reliability alternative part, you're going to have thicker layers. And then when you move from a high reliability alternative to a military or space grade component, you probably will have even thicker dielectric layers. So building the component more conservatively is certainly a part of it. And then the last part of it is the manufacturing process. If we look at the knives as an example, what we had discussed was that there's the forging and then there's the stamping process. And depending on which of those processes we use, determines really the reliability and the ability of the knife itself to maintain its sharpness and its durability. Well, the same thing happens with capacitors, inductors, and resistors as well. When we build these types of components, how we actually build them is going to affect the overall reliability. So we need to take care when we look at the material set, the conservative design, and then the manufacturing process in order to really build a very nice, very high reliability component. And then the next part of that is the qualification process itself. Once we've picked out the design and everything seems to be right, we then have to start the process of being qualified to whatever that governing spec is. What ends up happening is if we pass all of the requirements, then typically we will be added as a source. If we don't pass the requirements, unfortunately, we have to go back to the drawing board. In that case, we have to either change the design, the material set, the manufacturing process. Something has to be changed in order for us to meet the requirements. And if we look at something like the AEC-Q 200 versus, let's say, a MilPerf 32535, the qualification of the automotive parts might require 1,000 or 2,000 hours under certain conditions, while that mil spec would require multiple thousands of hours, 4, 5, or more thousands of hours, or even longer, in order to become qualified to it. So they have to meet that lifetime expectancy under some accelerated conditions without failing. And then there's also other things like material traceability, burn-in voltage conditioning, which also have a factor. When you look at the material traceability, there's not a lot of traceability that comes from commercial products. We have a bit more traceability for automotive products. We certainly are able to trace down where the materials are coming from and where they're placed into the components. But when we look at an aerospace or defense type of product, we know exactly who built the parts, meaning our operators on what line, what batch of materials are being used, and what day each of the processes were completed and when they were shipped out to the customer. So the level of material traceability becomes more and more important as we get up into higher reliability components. When it comes to something that's being sent up into space, like a deep space satellite, if something were to fail, they need to be able to track it back to what actually happened. So it becomes even more important to know exactly what batch of materials everything is coming from. And then, of course, testing is a part of reliability. Like I said, it doesn't make a part reliability. It proves that a part is reliability. And within the YAGEO Group, especially with the high reliability Kemet brands that are sold into medical, aerospace, and defense, there's all kinds of other testing that you typically wouldn't get out of a commercial or automotive grade product that will make the component more reliable. Something like our simulated breakdown screening or surge current testing or something of that matter is really what's going to, make the testing process weed out all the components that might fail. And then really the final part of it is the design and change control. What I mean by that is if we look at our commercial products, really the whole idea is to continue to evolve those products to be able to suit things like lower cost, higher volumes, to be able to manufacture them more efficiently. And with that, not just the YAGEO Group, but really any manufacturer on Earth has the ability to change those designs. Within the YAGEO Group, we will notify customers if we change something specifically related to the datasheet. But the key thing is that we don't actually need any of our customers' approval to do that. When we start looking at automotive grade products or the high reliability military and space grade products that are governed by the Automotive Executive Council or the DLA, what we end up seeing is that those types of components have to have design change control, meaning we can't change the part without the end customer's approval. So all of these things together is really what makes a component reliable. It's not just testing. Testing, again, really only proves that the part is reliable.
That makes sense. Now, Sam, overall, what kind of trends are you seeing in the electronics industry today?
I think it all comes down to three things: smaller, cheaper, faster. Customers are looking for more and more smaller components, and we're certainly working towards supplying those types of components to our customers. If we look at the YAGEO Group, I know we have 01005K sizes. I know we're working on 0075K sizes and 0050K sizes. To put that into perspective, some of the components that are on the finger on the screen are 0201s. We've gone well beyond that. And, my understanding is that some of these components are actually as thin as a hair. So we're looking at smaller components. Customers are looking for cheaper components. Like I said, when it comes to the commercial grade components for consumer electronics, really the whole idea is to be able to mass produce as many of these for as lowest cost as possible. Our customers approach us every year and say, hey, you sold this part for X price. Can we get it for less this year? So they're looking for less expensive solutions, and as electronics continue to evolve, we're able to provide less expensive solutions as well. And, that's going to be the case really across the board, not just with consumer electronics, but also the automotive, the downhole, and even in some of the high reliability applications as well, like defense and space. And then, of course, faster. Being able to provide the components in a timely manner is always important. I think one of the things that, over the last couple of years between the MLCC shortage and then, of course, COVID has really gotten everyone to think about is where can I get the components and where could I get them right now? And seeing some of these components being available right there online, especially with Mauser. If you go online on their website, they have a lot of these components that we're able to supply, and they're able to buy them directly from them and have them on their doorstep within just a couple of days. If we look at some of the high reliability components, it takes us time to manufacture those parts, do the testing, and typically those types of components aren't stocked in distribution. Some of them are, but a lot of them are not. And that's really the concern for customers, is just being able to get the components right when they need them in order to do their testing, their qualification, and then, of course, their end design.
Okay, so Sam, if my audience wants more information, where should they go?
Yeah, so the best thing that you could really do is go to Mauser.com. We have a web page set up that talks about the differences in the reliability grades. But of course, at any time, if you want to reach out directly to me, I'm happy to have a conversation with anyone between the differences between the commercial, the automotive, and high rel components. We're really just here to support you and make sure that you understand exactly what you're buying when you buy these different types of components. The reliability grade does make a difference, and depending on what you're designing, sometimes the consumer electronic product is perfectly fine. In other cases, you might need high reliability. So feel free to reach out anytime. We're happy to get on a call and support you any way we can.
Fantastic. Well, Sam, I think that's all I have time for today. Thank you so much for joining me. And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from the YAGEO Group. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it. It's right across the top. Or head on over to YouTube, youtube.com/EE Journal.